Welcome. Today we'll learn how to determine the appropriate sample size for estimating a population proportion using high-speed internet access as our example. The formula for calculating sample size when estimating a population proportion is n equals z squared times p hat times q hat divided by e squared, where n is our sample size, z is our confidence level value, p hat is our prior estimate of the proportion, q hat is 1 minus p hat, and e is our margin of error. Let's discuss the confidence level first. Common confidence levels are 90%, 95%, and 99%. These correspond to z-values of 1.645, 1.96, and 2.58 respectively. For our prior estimate p-hat, we need some idea of the proportion we're trying to estimate. This could come from previous studies, pilot studies, or industry data. If we have no prior information, we use 0.5, which gives us the largest sample size, and is therefore the most conservative approach. The margin of error east represents how close we want our estimate to be to the true population proportion. Common values are plus or minus 3%, or 0.03, and plus or minus 5%, or 0.05. Let's work through an example. Suppose we want 95% confidence with a margin of error of plus or minus 3%. And based on a previous study, we estimate that 60% of adults have high-speed internet. Plugging these values into our formula, z equals 1.96, p hat equals 0.6, q hat equals 0.4, and e equals 0.03. This gives us a required sample size of 1,024 people. If we had no prior estimate and used the conservative value of p hat equals 0.5, our required sample size would increase to 1,068 people. This larger sample size gives us more confidence in our results when we're more uncertain about the true proportion. Remember, larger sample sizes give us more precise estimates, but they also cost more time and money. The key is finding the right balance between precision and practicality for your specific research needs.